In today's video, we're going to be talking about problem G of Codeforces round 1054, division 3. In this problem, you're given an array of n integers called performance records and Q queries. Each query specifies a subarray, L to R, and we need to find all the record values that occur strictly more than length over 3 times, where length is R minus L plus 1, obviously. So how would we solve this problem? I would first make a claim, and this claim is that if the value v is part of the answer, then we would be able to find some index x satisfying ax equals to v, where x is between L and R, obviously. We would be able to find some index satisfying ax equals to v using a sufficiently low number of samples, where each sample refers to an index x in between L and R. Okay, so with that in mind, how would we be able to solve this problem? So this is actually a hint to solve this problem using a randomized algorithm. So this randomized algorithm would work as follows. So we would sample some number of points, some indices, in LR. And then the second step of this algorithm would be to check whether each value, okay, maybe I should say sample some values, and then we check whether each value indeed occurs length over 3 times. Okay, so yes, so the second part is actually a relatively standard problem. So if we are given a value v, if we want to check whether this value indeed occurs over length over 3 times, we can just keep track of a list of indices associated with each value. And then we just have to look at the first and last occurrence of this value, and then we would be able to obtain the number of occurrences through this information. Okay, so finally we just need to sample some values. So how many values would we be taking? So this might be a relatively small number, so we don't want to sample too many values, since if we sample too many values, we would risk getting time limit exceeded. So what is a good number of values for us to sample? So here we would need to actually calculate the probability of success for each sample. So yeah, so if the value v is part of the answer, if I do a total of C samples, then the probability of all the samples failing to find v is equal to, well, or we should say approximately, two-thirds to the power c. Since we are sure that if v is part of the answer, then v occurs at least length over 3 times. So there is a 1 in 3 chance that we would actually be able to find v using one sample. So that means there's a 2 in 3 chance of not finding it in one sample, and hence there's a 2 over 3 to the power c probability of all the samples failing to find v. So with that, at least one sample succeeding, that would be 1 minus this. So it turns out that we actually don't have to choose c that is too large. In fact, something like c equals 45 would be sufficient. By performing these two steps, we would be able to find all the values that actually occur length over 3 times with high probability. Yes, now let's move on to the implementation. So we would first perform the input. And we notice that the integers are between 1 and 10 to the 9, but it might be helpful for us to perform a discretization here. So we will first discretize the values. Yes, so we have discretized the values. So let's replace AI with its discretized version. And then now we have all integers in between 1 and n. So now we need to remember in the second step of the algorithm, we need to check whether each value indeed occurs length over 3 times or more. So we need to keep track of a list of indices associated with each value. So that would be this list for each value. Okay, now we move on to answering the queries. So we read in L and R. And then we want to sample, let's say, 45 times, right? The thing here is, if we actually sample only 45 times, we might run into some samples that are the same value. And if we checked one value once, there's no need to check it again. So in fact, we only want to check for 45 distinct values, but not 45 indices, because some indices could very well be repeated, and we could be wasting our time on these like duplicate values. So maybe we could, let's say we would limit the number of total tries to 200. And then we, of course, we maintain a set of answers and maybe failed attempts. And here we have, and here we are going to sample an integer from L to R and then take a of that, so the random index. So x would be the value that we want to try. Okay, so firstly, if failed attempts includes x, continue. If answers include x, there's no need to do anything as well. And here we should also maintain a global counter for the number of distinct values that we actually care about. Tries, or maybe like distinct tries. And then we could say distinct tries can at most be 45. So now our final goal is to check if x occurs length over 3 times in L to R. So how would we achieve that? Remember, we have lists for each value. So we're just going to binary search on this list. And then we see the borders of which x occurs in L to R. So here we firstly binary search for the lower bound. And then secondly, we would search for the upper bound. So here it would be greater than, smaller than or equal to R. And then finally, we'll check the actual number of occurrences. Is it actually at least length over 3? So the number of occurrences would be equal to LB2 minus LB1 plus 1, right? So if this actually occurs length over 3 times, then we add that to answers. Otherwise, we add that to failed attempts. course, we need to increment the number of the stick tries by 1. So that is it. We finally just need to actually answer the query. If there's no answer, no solution, then output -1. Otherwise, output all the answers. But remember, we have discretized our answer and we need to get back its original value. So let's test our code on a sample and see if it works. It's a minor bug here. The code seems to be working as we wanted, so let's test it out on the actual tests. Yes, so we have passed this problem. I hope you enjoyed today's video and found the problem interesting. If you like this video, be sure to comment, like, and subscribe to my channel. Feel free to suggest problems that you want me to go over in the comments or in the opinion box, link in the video description. Thank you for your support, and I'll see you in the next video.